Welcome back to the Deep Dive. Today, we are tackling a monster. And I don't mean a movie monster. I mean the absolute beast that is the modern artificial intelligence landscape. We are talking about the sheer, overwhelming complexity of trying to build something real in 2026.
It is a monster. I think overwhelming is the perfect word for it. If you look at the state of the industry right now, the number one sentiment we hear isn't excitement, it's paralysis.
Total analysis paralysis. I mean, put yourself in the shoes of a developer or a CTO right now. You wake up, you check your feed, and there are 3 new foundation models released overnight. There's a new vector database. There's a new framework for orchestration. And you're sitting there thinking, okay, we need to build an AI strategy. But you can't even pick the first tool off the shelf because the shelf is like a mile long.
And half the tools on that shelf didn't exist 6 months ago. That's the problem. It's not just that there are choices, it's that the choices are shifting under your feet. Companies get stuck in this loop where they spend months just stitching things together. They grab a data tool from vendor A, a training rig from vendor B, a deployment server from vendor C, and then
they realize none of them speak the same language.
Exactly. They spend all their time on the plumbing.
The famous Frankenstack. You spend all your time plumbing and no time actually solving the business problem. And that is exactly why we are focusing on today's topic. We are doing a deep dive into Vertex AI on Google Cloud.
And the reason isn't to read you a spec sheet. It's because the reading we've done suggests that Vertex is trying to solve that specific paralysis. It's pitching itself not as another tool, but as the whole toolbox.
Precisely. If you want a single metaphor to hold in your head for this entire hour, think of a Swiss Army knife.
The Swiss Army knife, I love that image. It's classic. It really is the core concept here. Think about why you carry a Swiss Army knife. You don't carry it because it has the world's greatest pair of scissors or, the world's longest saw. You carry it because it is unified. You have one handle. You open the red box and everything you need. The knife, the screwdriver, the corkscrew, it's all right there, integrated into one chassis.
And that's the unified platform pitch. In the cloud world, they call it a single pane of glass, which is a fancy way of saying stop logging into 50 different websites. Whether you are the data engineer trying to clean up a messy CSV file, or the scientist training a massive neural network, or the ops person trying to keep the server from crashing, you should all be looking at the same window.
Exactly. So the mission for this deep dive is to unpack that knife. We are going to pull out the blades one by one. But we aren't just listing features because that is boring and, frankly, unhelpful. We are going to map this to problems. The format today is simple. I have problem X. Which tool do I pull out of the Vertex box?
I like that, practical. And just to orient everyone listening, whether you are an engineer who dreams in Python or a manager who just wants to know why your client bill is so high, we are going to strip away the jargon. We are going to cover the essential basics and the intermediate workflows. We want to get you to that point where you understand how the machine actually ticks.
We'll go from the essential to the expert, but we will keep it grounded in reality.
So let's start with the handle of the knife, the platform itself. Why does this unified thing matter so much? Why shouldn't I just go out and buy the best-of-breed tool for every single tiny step? I mean, I like buying specialized gear.
You can, and many people do, but you pay a tax. We call it the integration tax.
Yeah.
Let's look at a scenario from our research stack here. Imagine a data science group at a mid-sized company. They aren't just doing one thing. They have, let's say, 25 distinct machine learning initiatives running at the same time.
25. That's a lot of spinning plates.
It's massive. You might have one team working on a customer churn model. That's classic predictive stuff. You have another team trying to build a generative AI chatbot for customer support. You have a third team doing image recognition for quality control on a factory line.
And if they are all using different tools.
It's chaos, absolute chaos. If you don't have a unified platform, just think about the overhead. You have 25 different data pipelines. You have 25 different training environments. You have to manage user permissions for 50 people across 10 different software vendors. Oh, Bob left the company. Did we remember to revoke his access to the vector database?
That sounds like a security nightmare waiting to happen.
It is. And it's not just security, it's about lineage. If you use BigQuery for your data, but some random startup's tool for training, and then another tool for deployment, you lose the thread, you lose the story. You can't easily answer the question, which specific data set created this specific model that is currently annoying my customers?
Right, you lose the audit trail. There's no flight recorder.
Exactly. Vertex AI positions itself as the umbrella. It manages the full life cycle. So for that team with 25 initiatives, they can trace a line from the raw data all the way to the final API call, all within one system. That is the value of the handle. It's the infrastructure of organization.
Okay, so that's the philosophy.
Mhm.
Stop gluing things together. Now let's start opening the blades. I want to start with the most common problem right now.
Okay.
The problem of I need it yesterday.
Speed to market. The pressure is on. It's immense.
Right. I'm a startup founder, or maybe I'm a product manager at a big bank. I have an idea for a feature. I do not have 6 months to hire a research team. I do not have $10 million to train a model from scratch. I just want to plug AI in and see if it works.
Then you do not build. You buy, or rather you borrow. You open the blade called Model Garden.
The model garden. It sounds remarkably peaceful for a high-tech software product, like I should bring a picnic basket.
It is a bit of a serene name, isn't it? But think of it as the App Store for AI models. Or maybe a library is an even better analogy. It is an interface where you can browse, discover, and deploy pre-trained models.
So this addresses that build versus buy friction directly.
Directly, 100%. The source material mentions a specific scenario. A product manager needs to prototype a summarization feature for their app. They have a 45-day deadline to get a pilot running. They simply cannot gather a dataset, clean it, design a model architecture, and train it in 45 days. It's physically impossible.
So the old days, they would just be stuck. The idea dies on the whiteboard.
Right. But now they go to the model garden. They literally go to a search bar and type summarization, and they are presented with a list of options.
No, when you say options, what are we looking at? Is it just a list of cryptic names? What do I see?
You see model cards. This is a really important concept. Think of a model card like the nutritional label on a box of cereal.
Okay, I like that. Contains 100% artificial intelligence. May contain traces of bias.
Exactly. But more importantly, it tells you the ingredients. It tells you the parameters. How big is the model? It tells you the intended use cases. Is this good for medical text or is it better for coding? And crucially, it tells you the limitations and the licensing.
Licensing is the landmine, right? Because I
Yeah.
imagine you don't want to accidentally build your company's core product on a model that has a license saying academic use only.
That is a disaster scenario, a total showstopper. You build the whole thing, legal looks at it the day before launch and shuts you down. Model Garden standardizes that information so you can see it up front. And here's the key insight that I think surprises people. The Model Garden isn't a walled garden.
Meaning it's not just Google stuff. It's not just Gemini this and Gemini that.
Correct. It is a mix, a marketplace.
Yeah.
You have Google's proprietary models like Gemini Pro or Imagen, which are accessed via API. But you also have the open source heavyweights. Llama 3 from Meta is there. Mistral from France is there. Gemma, Google's own open models are there. It's a whole ecosystem.
So if I want to use Llama 3, why wouldn't I just go to Hugging Face or GitHub and download it myself? Why do I need Vertex for that?
You can download it, but then you have the deployment headache. You download the weights, which are gigabytes and gigabytes of files.
Oh.
Now what? Now you have to provision a server, you have to install the right drivers, you have to make sure your CUDA version matches the PyTorch version, you have to containerize it, you have to set up the API endpoint, you have to secure it.
It's the milling your own flour versus buying the cake mix analogy again.
Exactly. Like, I love that analogy because it's so true. If you download it yourself, you are growing the wheat and milling the flour. In Model Garden, for many of these models, there is a one-click deploy button. You click it, and Google Cloud spins up the infrastructure, loads the Llama 3 weights, optimizes the container, and hands you an API endpoint.
So you're saying that whole list of chores you just mentioned.
Gone. You are running an open source model, but with the convenience of a managed service.
That is a significant accelerator. Instead of spending 2 weeks on infrastructure, you spend 2 minutes clicking a button.
And for that product manager with the 45-day deadline, that is the difference between shipping and failing. It's that simple.
Okay, so I've gone shopping. I've bought my cake mix in the Model Garden. Maybe I grab Gemini Pro, or maybe I grab Llama 3. But rarely does a model work perfectly out of the box for a specific business, right? I need to tweak it. I need to add my own data. I need to write code. I need a place to do the actual work.
You need to enter the workshop. This brings us to the next tool in the knife, Vertex AI Workbench.
The workbench. This sounds like where the messy work happens. The sawdust and the glue.
It is. This is the Integrated Development Environment, or IDE. And for the technical listeners under the hood, this is built around Jupyter Notebooks.
Which is the standard. If you walk into any data science department in the world and look at a screen, chances are you're looking at a Jupyter Notebook. It's the lingua franca.
You live and die by it. It's where you write code, visualize data, run experiments. But here's the problem with standard Jupyter. It usually runs on your laptop.
Which is fine until you try to load a 50-gigabyte data set and your fan starts sounding like a jet engine.
Or it just crashes.
Or it just crashes. Or until you spill coffee on your laptop and lose your work.
Mhm.
Or, and this is the most common one, until you want to share your code with a colleague and it doesn't run on their machine because they have a different version of Python installed.
It works on my machine is the most dangerous phrase in engineering history.
It really is. Vertex AI Workbench solves this by being a managed notebook instance. It runs in the cloud. That gives you two main things: power and collaboration.
Let's talk about power first. What does that mean in practice? Since the notebook is running in a Google data center, not on your desk, you can attach massive compute resources to it instantly. You can be in the middle of coding and say, hey, I need 4 A100 GPUs for the next hour to run this training job. You click a button and the notebook has that power. Your laptop is just a remote control. You could be doing this on a cheap Chromebook and you're wielding the power of a supercomputer.
That's a cool image. Typing on a lightweight machine, but the heavy lifting is happening in a data center thousands of miles away. And collaboration, how does it help there?
Since it's a managed service, your team shares the same environment. You can share direct links to notebooks. You have access to the same data sources. It's connected to your cloud storage. It solves the versioning nightmare. It solves the works on my machine problem. It's the shared space where the team comes together to actually build. It bridges the gap between the I bought a model phase and the I am building a product phase.
Okay, so we are moving up the complexity ladder. I have the model from the garden. I have the code working in the workbench. I've customized it. It works. But now I have a new problem. I can't be sitting there manually running this code every single time I get new data. That's not a business process.
Right. You can't have a human being, an expensive data scientist sitting there clicking run in a notebook every morning at 9 a.m. That is fragile.
Humans are terrible automation engines. We get tired, we forget steps, we get distracted by Slack messages, we make mistakes.
Exactly. You need to move from the craftsman's workshop to the factory floor. You need an assembly line.
And that tool is Vertex AI Pipelines.
Pipelines. This is the orchestrator. It automates the entire machine learning workflow from end to end.
So break down that workflow for us. When we say workflow, what are the actual steps on this assembly line? It's more than just train model, right?
Oh, much more. Think about the life cycle of a living model. It's not just train once and forget. First, you need to ingest new data, maybe yesterday's sales figures. Then, you need to validate that data to make sure it isn't garbage. Then, you need to maybe pre-process it, fine-tune your model on that new data. Then, and this is key, you need to evaluate the new model to see if it's actually better than the old one. And finally, only if it is better, you deploy it into production.
And Pipelines connects all those dots. It makes them run in order.
It connects them, but the smart glue analogy is better here. It doesn't just run them blindly. It supports conditional logic.
Conditional logic. That sounds like programming. Give me a concrete example of how that saves my bacon.
Let's look at that evaluation step. You have an automated pipeline that retrains your fraud detection model every week on Sunday night. The pipeline finishes training a new version. But before it pushes that new version to your customers, the pipeline runs a test. It asks a question. Is this new model at least 99% accurate on our holdout data set?
And if it's only 98%, maybe something was weird in the data that week.
The pipeline hits a gate. It stops. It sends an alert to the data science team saying, hey, the new model failed quality control. It does not deploy. It leaves the old, reliable model running.
That is critical, because otherwise, you might automatically push a dumber model to production just because it's Monday. You could be costing your company millions without even knowing it.
Exactly. We call this preventing regressions. Pipelines allows you to codify the best practices of MLOps machine learning operations. It turns a science experiment into a reliable, repeatable, industrial-grade software product. It ensures that the factory doesn't just produce more, it produces quality.
So, quick recap. We have the garden for discovery, the store. We have workbench for development, the workshop. And we have pipelines for production, the factory. That covers the software layer of the Swiss Army knife.
It does, but software is ghost code without hardware to run on. We need to peel back the casing of this knife and look at the engine, because none of this works without the physical chips.
The infrastructure, the engine room. This is where the cloud wars are really being fought, isn't it? It's all about who has the best metal.
It is. Compute power is the currency of the AI age.
So we need to talk about chips. Most of our listeners know CPUs. That's the chip in your laptop, the Honda Accord of chips. Reliable, flexible, does everything pretty well. And they know GPUs, the sports cars, originally for video games, now for AI. But Google have this third player on the field, the TPU.
The tensor processing unit.
Now why? Why did Google spend billions and billions of dollars building their own custom silicon when GPUs from companies like NVIDIA are already so good?
Because of specificity. A GPU is a sports car, yes. But remember, it was originally designed to render pixels. It was designed to figure out how light bounces off a 3D dragon in a video game. It just happened to be really good at the math needed for AI, which is matrix multiplication.
It was a happy accident, a very profitable accident.
Exactly. But the TPU is a Formula One car built for exactly one track, and that track is matrix math.
Matrix math. It sounds like a painful high school class.
It's the engine of deep learning. At its core, all this complex AI is just multiplying massive grids of numbers matrices together, over and over again, billions and billions of times. The TPU architecture is designed to flow data through the chip in a specific systolic array pattern that is hyper-efficient for that specific math. It strips away all the other stuff a chip usually does. So
you wouldn't use a TPU to host your website or run a database?
Absolutely not. It would be terrible at it. It's not a general-purpose tool. But for training a multi-terabyte scale large language model, it's a beast.
Now, looking at our notes here, there is a very specific technical detail about why TPUs are better for these massive models. It's not just the chip itself, right? It's how they talk to each other.
This is the expert insight that often gets missed. People obsess over the chip speed, the teraflops. But when you are training a massive model, like a GPT-4 or a Gemini, it does not fit on one chip. It doesn't even fit on 100 chips. It is spread across thousands of chips.
So they have to collaborate. They have to constantly compare notes on what they're learning.
Constantly. They are constantly syncing their parameters. And that chatter, that communication between chips, that is the bottleneck. In a standard GPU cluster, chips often communicate over standard networking, like Ethernet. It's fast, but there is overhead. There is latency. Think of it like shouting across a crowded room.
And what do TPUs do differently?
They use ICI, chip interconnect.
ICI.
Think of it like this. Instead of shouting across a crowded room, the chips have a direct, hardwired neural link to their neighbors. It is a specialized, high-bandwidth, low-latency cabling system that bypasses the standard network stack entirely. It's a private, super-fast network just for the chips.
So it's like they are telepathic.
In a way, yes, it creates a supercomputer mesh. This allows for massive model parallelism. You can split a giant model across thousands of cores, and they act like one single giant brain because the communication penalty is so low. That is the architectural advantage.
That is fascinating. So while everyone else is stuck in traffic on the Ethernet highway, the PPUs have their own private subway system.
That's a great way to put it. It's purpose-built for AI communication at scale.
Okay, so we have the F1 cars. But F1 cars need fuel, and in the AI world, fuel is data. Where do we put all this stuff? The images, the PDFs, the messy, unstructured chaos that is real-world data?
You need a warehouse, and in Google Cloud, that warehouse is cloud storage or GCS.
GCS. This seems like the boring part of the stack. It's just a hard drive in the sky, right? Why is it special?
It is, but the scale changes the physics of it. The source material mentions a specific case. An agency storing 32 terabytes of source images for model training.
32 terabytes. That is a lot of JPEGs. I can't even imagine that on my laptop.
It is massive. Now, where do you put that? You cannot store that in a traditional database. It would be astronomically expensive and slow. You cannot store it on a local block disk attached to a server. It's too hard to manage and hard to share. You need object storage.
Why object storage specifically?
Because it is elastically scalable. You throw data in, and the warehouse just gets bigger. You don't have to call IT and ask for another hard drive. You never run out of shelf space. And crucially, it separates the storage from the compute.
What does that mean, separate storage from compute? Why is that important?
It means you can have 32 terabytes of data sitting there cheaply. Object storage is very cost-effective. And then, only when you need to train, you spin up your expensive TPU cluster. The TPUs reach into the warehouse, grab the data, process it, and then you shut the TPUs down. You aren't paying for the expensive F1 car to just sit in the garage holding the data.
That's a huge cost factor. The warehouse is cheap, the race car is expensive. Only drive the car when you need to race.
Exactly. And GCS is designed to have massive throughput to feed those TPUs. It's the high-pressure fuel line that can keep the F1 engine from starving.
So we have the workbench, the pipelines, the F1 cars, TPUs, and the warehouse, GCS. We are building a serious operation here. But power without control is dangerous.
With great power comes great responsibility. It's a cliche for a reason.
Indeed. We need to talk about the things that keep executives up at night. Governance, safety, keeping it legal.
This is the seatbelt and airbag section of the car. The unglamorous but absolutely essential part.
Let's talk about a problem that sounds boring but is actually terrifying. The lost recipe problem.
This is a classic nightmare scenario. Imagine you are a bank. You have an AI model running in production. It's deciding who gets a mortgage and who doesn't. It's a high-stakes model with real-world impact.
Okay, I'm with you.
Suddenly, an auditor walks in, maybe a government regulator. They ask, hey, this model rejected my client. Prove to me that it wasn't biased. Show me exactly what data it was trained on. Show me the code that built it.
And the engineer says, I think it was a file named Final Models D2RE vinyl.pt on Dave's laptop.
And Dave quit 2 months ago to go join a crypto startup.
Disaster. Total unrecoverable disaster.
Complete disaster. You have lost the lineage. You have the cake, but you have lost the recipe. You cannot prove how it was made. You're facing fines, lawsuits, reputational damage.
So what is the Vertex solution to this? How do we find the recipe?
Vertex AI Model Registry.
The registry.
Think of it as an immutable library card catalog, or a very, very strict inventory system. Every time you train a model that passes your tests, you register it in the system. But it doesn't just save the model file itself, it saves the metadata.
Metadata. So it connects the dots backward. It builds the family tree for the model.
Yes. That's a perfect way to put it. It says, this specific model version 3.4, was trained on this specific dataset hash using this specific training pipeline with these specific hyperparameters. It links everything together.
It's a flight recorder.
Exactly. It provides auditability. If you are in finance, healthcare, or government, this isn't a nice-to-have feature. It is regulatory survival. You need to be able to prove the origin of your intelligence. If you can't trace the lineage, you shouldn't be running the model, period.
That makes a ton of sense. It's about accountability. Speaking of accountability and rules, let's talk about the passport control, data sovereignty.
This is a huge topic right now. The concept of data residency.
Breaking it down. We tend to think of the cloud as this nebulous, global thing that floats everywhere. But laws are very specific about geography.
The internet is global. The law is local. That is the fundamental tension. A German insurer or a French government agency or a Canadian bank often has very strict requirements. They might say, data regarding our citizens cannot leave the physical borders of the European Union, or Germany, or Canada.
So if I use a cloud API, some cool new model, and that API sends my data to a server in Iowa to be processed.
You have broken the law. You are non-compliant, and the fines for that can be enormous.
So how does the Swiss Army knife handle that? Because Google is a global company. How do they put up fences?
Through regionalization. When you set up resources in Vertex AI, whether it's a training job or a storage bucket or a notebook, you pin it to a specific region. You say, everything happens in Europe West 3, which is Frankfurt.
And Google guarantees it stays there. The bits don't leak out.
Yes, the data stays there. The processing stays there. But, and this is a really important constraint, this sometimes limits which blades of the knife you can use.
How so? What do you mean?
Well, think about those big, flashy SaaS APIs. Some of the newest, biggest generative AI models might be hosted in a massive supercluster in the US because they are just so enormous. If you have strict sovereignty requirements in Germany, you might not be able to use that API. You can't make that call.
You can't use the call-out blade, so to speak.
Right. The expert insight here is that you might have to pivot strategies. You might have to go back to the model garden, grab an open-weight model like Llama or Gemma, and host it yourself on your own reserved instances within that Frankfurt region. You bring the model to the data, not the other way around.
So the platform supports both approaches, SaaS or self-hosted, but you have to know which one keeps you out of jail.
Exactly. The toolbox gives you the option to be global or local, but you have to make the choice based on your regulatory handcuffs.
That's a crucial distinction. It's not just, does it work? It's, is it legal?
Always. And compliance is a huge driver of architectural decisions.
Okay, we have covered the platform, the infrastructure, and the rules of the road.
Yeah.
Now, I want to do something a little different. We've been talking theory. Let's talk practice.
I like it. Let's get into the weeds.
Let's do a rapid fire round.
Yeah.
I'm going to throw a specific, messy, real-world headache at you. Something that happens on a Tuesday afternoon when things are going wrong.
Yeah.
You tell me which tool from the Vertex box fixes it. The Fix-It Kit.
I am ready. Hit me.
Scenario A. The rotting model. My model was a genius in January. It predicted sales perfectly. It is now March, and it is giving me garbage answers. It's totally failing. What happened?
Classic problem. That is prediction drift.
Drift, like it's drifting away from reality.
Yes. The world changes, but your model is static. Maybe user behavior changed, maybe the economy shifted, maybe a competitor launched a new product. The source example is a support assistant trained on 6-year-old logs. It cannot answer questions about a product launched 45 days ago. That is a failure of relevance.
So what's the tool? How do I even know this is happening before my customers start screaming?
Vertex AI model monitoring.
How does it work? Is it magic?
It's a smoke detector. It's statistics. It watches the live data coming into your model 24/7. It compares the statistical properties of that live data against the data you trained on. If they start to diverge, if the distance between the distributions gets too big, it fires an alert.
So it tells you, hey, reality is changing. Your model's getting stale. It's time to retrain it with fresh data.
Exactly. It catches the rot before it destroys your user experience or your bottom line.
Nice. Okay, scenario B, the mystery decision. The AI rejects a loan application. The customer is angry and asks why. The engineer looks at the neural network and just sees a bunch of numbers. They shrug.
The black box problem. This is a huge issue. You need Vertex explainable AI.
Explainable AI, does it really explain what's going on in that brain?
It runs a post-hoc analysis on the prediction. It uses techniques like integrated gradients or Shapley values to tell you feature attribution.
In English.
It tells you the why behind the what. It says, I rejected this loan because the feature income was low and the feature debt-to-income ratio was high. It breaks down the decision logic into human understandable terms. This is critical for debugging bias. If the model says, I rejected this because of zip code, you might have a hidden bias problem you need to fix.
Essential. Okay, scenario C, the copy-paste nightmare. Team A calculates customer lifetime value one way. Team B, in another department, calculates it a slightly different way. The training data doesn't match the live data. It's a mess of inconsistent definitions.
This is a silent killer of ML's projects. It's called training serving skew. The solution is Vertex AI Feature Store.
The feature store.
Think of it as a shared pantry for a restaurant. Instead of every chef buying their own ingredients and chopping them differently, you have pre-chopped, standardized ingredients in the pantry. You define customer lifetime value once as a feature. Everyone. The training pipeline, the real-time serving endpoint, the analytics team pulls that same definition from the feature store. It ensures consistency across the board.
Shared pantry. I like that. So everyone's using the same ingredients. Okay, scenario D, the budget constraints. I'm a retail startup. I built a cool style recommendation app, but no one uses it at 3 a.m. I do not want to pay for a GPU sitting idle in the middle of the night burning cash.
You need Vertex AI endpoints, specifically the serverless option.
Serverless. That's the magic word in cloud computing. What does it mean here?
It scales to 0. That is the key phrase. If you have no traffic, the number of machine instances goes to 0, and your bill for that compute goes to 0. But the moment a request comes in, it spins up in milliseconds to serve it. You only pay for what you use.
And there's a traffic splitting feature here, too, for testing.
Yes. The source mentions a startup that needs to A/B test a new recommendation model. You can configure the endpoint to say send 10% of traffic to the new version and 90% to the old stable version. It handles that routing for you seamlessly so you can test in production safely.
Perfect for A/B testing. Okay, scenario E, chat with data. Everyone wants to build a ROG application right now, retrieval augmented generation. I want to chat with my company's internal PDFs. I need to store vector embeddings.
Standard databases like BigQuery Standard or Cloud Storage are not optimized for this. You need a specialized tool. You need vector search. Or, if you are in the Postgres world, AlloyDB for PostgreSQL with PG Vector.
Vector search. What makes it different from a normal keyword search that I'd use in, say, a document?
It's designed to find nearest neighbors in a high-dimensional space. It finds things that are conceptually similar, not just keyword matches. If you search for ways to improve employee happiness, a keyword search looks for those exact words. A vector search understands the meaning and might find a document that talks about boosting team morale or creating a positive work culture, even if it doesn't contain your exact keywords. It is the engine that powers the retrieval part of RAG.
Last one. Scenario F, the image artist. I need to generate images of furniture from text descriptions for my e-commerce site. I don't want code. I don't want text summaries. I want pixels.
You don't use Gemini Nano or Cody for that. you grab Imagen.
Imogen.
That is Google's dedicated text-to-image foundation model. It is specialized for visual generation. It's the paintbrush in the toolbox. You have to pick the right tool for the job.
Boom. That was a workout. We just ran through the entire toolbox.
It is a lot, but you can see how they fit together. It's not just a random grab bag of tools. It's a system.
So let's zoom out for a second. We started this deep dive with that feeling of paralysis.
Yeah.
The messy workbench, the anxiety of choice.
And we ended with a factory, a well-organized, automated factory.
Exactly. We've gone from the hardware, those F1 card TPUs, to the storage warehouse, to the workbench for development, the pipelines for automation, the registry for governance, and finally the model garden for discovery, the whole stack.
The shift we are describing here, and this is the aha moment for me, is that AI is moving from an art to engineering.
Say more about that. That feels like a big statement.
Well, think about it. A few years ago, AI was artisanal. It was brilliant scientists in dark rooms tweaking algorithms, hoping for a breakthrough. It was experimental. It was chaotic. What a platform like Vertex AI represents is the industrialization of AI.
Moving from the garage workshop to the full-scale assembly line.
Precisely. It's about reliability. It's about repeatability. It's about safety and scale. It's about treating AI models not like magic tricks that might work on a good day, but like software products that need to be maintained, monitored, governed, and shipped on time, every time.
That is a huge shift in mindset. And it leads me to a provocative thought to end on.
What's that?
We talked about those two scenarios. The startup using the global model garden, downloading Llama 3 or hitting the Gemini API, and the German insurer or the government agency locking everything down in a local vault because of data sovereignty.
The tension between the global and the local, the open cloud versus the walled garden.
Exactly. We have these massive global cloud brains that are getting smarter every single day.
Yeah.
But we also have this increasing pull towards isolation, national borders, privacy laws, corporate secrets.
It raises a big question. Will the future of AI be one giant supermodel in the cloud that everyone taps into, a sort of utility? Or will it be millions of fragmented sovereign models locked in local vaults, never talking to each other?
Vertex AI seems designed to handle both, has the API blade and the custom hardware blade. But which way will the industry actually break? That is the billion-dollar question.
It is, and honestly, the answer is probably both, which makes the toolbox even more essential. You need to be able to cut both ways. You need a platform that is flexible enough to let you call the cloud when you can and own the stack when you must.
Well, there you have it, the Vertex AI Swiss Army knife. To our listeners, don't let the complexity paralyze you. The tools are there. Go open the box, pick up a tool, maybe start with Model Garden, and see what you can build.
Just remember to check the model registry so you don't lose the recipe.
Good advice. Thanks for listening, everyone. We'll see you on the next Deep Dive.